Welcome, everyone. Thank you for joining us for today's webinar. My name is Thelma Groh, and I'm the marketing manager here at INT. INT is the leading provider of upstream data visualization solutions for the energy industry. Today, we are presenting optimizing production geology workflows with IVAAP, presented by Raffik, Lazar. And just a few housekeeping things before we get started. If you have any questions during today's presentation, please type them into the question box in your Zoom control panel. We'll answer any questions after the live demo at the end of the webinar. And of course, if you have any questions following the webinar, please feel free to email us at marketing@int.com or info@int.com. Our presenter today is Raffik Lazar, founder and principal geo-consultant at GeomodL International. A geologist and geomodeler by background, Raffik has more than 17 years of experience in the industry, mostly with Shell International and with GeomodL International as well. He's also been a user of IVAAP for a number of years, so he can offer a unique perspective on how to use INT software to get the most from your workflows. So without further ado, now we'll turn it over to Raffik. Raffik, whenever you're ready.
Hello, everybody. Thank you very much, Thelma, for the introduction. Let me walk you through a few slides before the demo. So today we are going to look at the production geology workflow enabled with IVAAP. My name is Raffik Lazar, and I represent GeomodL International. We are a consultancy based in the UAE. We specialize in carbonate reservoirs, reservoir modeling with petrol. We help our customers in all aspects of the life cycle, from exploration appraisal to FDPs and also mature fields. And we've developed a niche workflow called the seismic geomodeling. So, as you know, the reservoir life cycle starts with the exploration. Normally can take 2 to 3 years. We try to understand the geology of the basin, mostly based on seismic data. We drill exploration wells, sometimes we appraise as well, and then we develop concepts of the reservoir. Once we have the accumulation, which is commercial, we transition into a development phase, which in average could take 3 to 5 years, where we drill wells, we commission surface structures, and then we start to have first production data. And then there is the actual life of the field, so production time, where we produce the reservoir. Most of the time we drill additional wells because the dynamic behavior gives us new learning, production data as well. And that can take 10 to 30 years. It's important during the production phase to relook at initial plan, because basically it never goes as per the plan. And during that critical phase, as a geologist, as a geomodeler, what you do is you will juggle between the purely GNG data, so you can see core data, logs, seismic analogs and models. Of course, production data, dynamic data. So here you can see it's a pressure over time and a P over Z plot and the gas rate. It's very critical to help the understanding of the reservoir, especially its behavior. And then always there is a questioning, there is a challenging of current 3D static models. It's not a one-off, it changes through times. And with the help of the GNG data and the production, we refine the static model, and then we plan further development. Now, the daily pain points we have in the production geology space is that, as you have just heard from me, the data is located in a lot of platforms, different platforms and silos. Normally, the production data, it's in Excel format. The GNG data, sometimes it's in petrol, sometimes you have other data sets that you need to dig. So not straightforward. Then the way to visualize those data, most of the time it's not really formatted to derive instant knowledge. So for example, the production data you will see in the next slide, it's just a table in Excel, not really digest. And then I would say the most critical part is the data cross visualization. So the data by itself is not really integrated. And if you can do the integration, this is where you derive the understanding and the knowledge of the reservoir. So here it's an example of a pain point. So visualizing the data. So here you have production. It's a typical CSV file from Excel. Not really digest, very difficult, I think, to make sense. Now, if you format it, you see into a nice graph through times with different colors. Then clearly you can see the decline. You can see the water cut, very stable. And of course, that gives you much more information about this reservoir. We believe that in the production time, cross-visualizing the data is really the silver bullet, because it helps you to capture insights far better than looking at each of the data in isolation. Also, what I call the time to knowledge is much faster when you look at multiple data at the same time. And ultimately, that will cascade into better development decision. And of course, cost saving and optimization of your development. So here is an example which I did by hand. So you have a field map. So it's a gas field with wells, they are the square. And then on top, this is a production bar chart from Excel through times. So each of the color is matching with a well. And then you add the event in the field. So for example, you can see the red well, which is here. It's quite a good well. It came on stream and it delivered for a couple of years. The yellow well, which is the highest in the structure, is one of the best well until today. It's still giving. The green well as well, very high. And then some of the well died off very quickly, like the purple or the dark blue, because they are quite deep in the structure. So by combining GNG data, so the map and the well, with production data, we can, in a snap of a finger, we can understand behavior of this reservoir, of this field, and understand where are the better location for future development. Now, the problem is that as of today, that has to be done by hand. There's no real platform or tool to enable visualizing the data and cross-visualizing this data in a single location. Now, as a geoscientist, the solution that would be great for me if there is a platform, a single platform, where I can have the access to all the data, production data, GNG data, 3D models, and then I can visualize all of them at the same time. So that's actually the case with IVAAP. So it's a tool that has been developed by INT. And we can basically visualize all the data, production data, GNG data, and model in the same platform. And I'm going to give you a demo right now. We choose the field of Koevoorden. It's a gas field in the Netherlands. It's still operating as of today. It's operated by the NAM, which is a JV between Shell and ExxonMobil. Very mature fields, quite massive in terms of gas in place. Still a lot of potential. Yeah. So let's now transfer to the IVAAP platform on Google Chrome, and let's have a look at the production geology workflow in IVAAP. All right, so here I am. So the first thing is IVAAP. It's a web-based platform. So it's on a browser, which means that you do not need specific hardware, big machine to be able to do the work, to do the job. So when you start the homepage, you have a set of dashboards here, which you can open one by one. So let's start with the first dashboard. So the dashboard, basically, it's organized on the left. You have the data. You can see there are wells, tops, seismic, grid, and reservoir model. On the right, these are the parameters and the settings. And in the middle, in the center, these are all what we call a widget. So it could be a chart, it could be a map, a chart, 3D windows, and so on. So the first dashboard that is useful as a geologist when you start a project is to just look at what's the performance of your well, you know, and what you typically want to do is you can see on the top right, you have top reservoir map, yeah, which you can play with the settings, so you can do very similar things that you do with Petrel. So I can squeeze the color bar, for example, and stretch it as well. You can see I can zoom in and out. Then here on the left, this is the production through times. So the idea is to look at what is the production for each of the wells. So, for example, if I look at this group of wells, so it's, you can see on top here, it's 6 wells altogether, cumulatively on a monthly period. So the first thing I can do is I can change the time. I can look over a period of 10 years, for example, or I can focus on the last 2 years. So here you can see the contribution of each of those wells. For example, I can instead of having monthly production for each of the wells, I can have a cumulative plot. So you can see, and if again I change the history, then basically you will see from beginning of the period, which is 2011, what is the contribution of each of those wells in terms of gas production. You have the same thing for condensate and then for the water. So here you can see the red well, Covalent 18, which is somewhere here. So it has a good gas production, but also has significant water. If I go back now, I can probably look at absolute time. So I just change my time. You can see on the right. So here we start from 96. So we start from 2000, January 1st. Right. So here we have the full timeline from 2000 until today. So for example, you can see this well, the green well, Covalent 17, it produced for a while and then it stopped. Yeah. So that's really the first dashboards, which is really focusing on the production, trying to understand. Let's go to the second one. So in this dashboard here, you have multiple things. So on the same thing, you have all the data on the left. Now you have a well, a single well. If you want to try to understand, really go into the details. You have its production, its performance in the curve and in the table as well, if you want to have the exact value. And then on the right, on top, you have top reservoir, same. And then down, you have the 3D model. So it's interesting here because you see it's in the browser, but it's very smooth. So you can zoom in and out the 3D window. You can look at the well, and everything is fully synchronized. So when I touch the well in the 3D window, you can see as well on the top map which well I am touching. Same thing here. For example, this well, Covalent number 20. I'm scrolling in the well section here. You can see the cursor is moving in the map as well. Now let me go back to the well section. So you can see here there is a diagram of the well, so you can understand where are the perforation. If I can make it a bit bigger, as you can see, I can enlarge the track. So very similar to what you can do in Petrel. So you know the perforation are here, here, and here is your casing shoe. So here there's a gamma ray, and then there are neutron density. So very similarly to what you can do with Petrel, you can, for example, change value of your log. So I can go from 0 to 0.6, for example, for the neutron, but it's a gas field. I'm going to go back to 0, minus 0.15 and 0.45. You can play with the filling as well. Again, what you can do with Petrel, for example, filling here, I can reverse it, yeah, and I can change the value of high bound and the low bound. Right. On the production itself, we've looked at it, but basically you can go into details. You can see here that well. Water is in blue, obviously, and the gas is in gray. So this well has given a lot of gas. You can see, so the scale is on the left and the water is on the right. Some water cut as well. Now, if I go back to the 3D window, so this is the reservoir model. So you can see there's a couple of wells here. Here I am visualizing the property which is above contact, but I can change. I can put the porosity, for example, as you can see. We can put as well, for example, saturation of gas, yeah, and I can change the color scale. I can filter in and out. Okay, back to the above contacts or to the porosity. So basically here, as per the presentation, you can have under the same roof, in the same screen, your 3D model, your top reservoir map, your well schematic, and the well, the logs, and the production. I could change the well, for example. I could go, let me think which one would be a good example. Just a second, I'm looking for a good example. One. Okay, I will take Coordon 23, for example, replace it, Coordon 23. There you are. So you just drag and drop the new well, and then you go all the way now down to the reservoir. Again, you can see. So here, I can make a bit of space. So you have the logs, you have also porosity, saturation, you have perforation as well, and even I added the PLT, so you can see most of the contribution for the gas is coming for that interval here. So that was the production geology dashboard. So obviously there are some variations. So here, this is more like a dashboard for GNG. So what you have is correlation for a couple of wells. You can see there's a gamma ray and neutron density logs with some formation tops. You have, again, here in the 3D window, this time it's the top of the reservoir map. And on top here, it's a map view, again, of the top of the reservoir. So here, basically what you can do is you can, for example, move tops. So if I right click on the tops, I click on move tops, and I can just drag it up and down, for example, if I made a mistake. So you can adjust top, you can add tops as well. So again, in that context, for example, if you would be drilling a well in operation, you have a new well. So you could, with this tool in a browser, you could basically have your nearby wells, have your well that you are drilling, which, by the way, could be synchronized on real time. You can also look at it in 3D, and then as the data is coming, you can adjust your top, check versus the prognosis, and have basically a real-time information of what's going on with your drilling. That was more of GNG type of dashboard. And then the last one is more like a synthetic dashboard. It's, I think, more for production. So for example, if I'd like to analyze my production with more details. So here we have a well covered on number 20. So you can see there's a gas production in blue, and the water production is very minimal. You can see in yellow cumulative production through time. So the well is here, you can see in the map. Here it's more detailed. The interesting part here is that you can have at the same time look at the figures on the bottom right. So for example, here I am going to change Raffik the time. That's correct. And in terms of time, right? And I will take last 10 years, updating. That's fine. And I'm closing. So yeah, that dashboard is really more on the production guys to look exactly to analyze in detail what the production is doing. So that was a quick glimpse of what we could do with IVAAP and how we can replicate the production geology workflow. If you have any question now, I'll be happy. Thank you.
All right. Thank you so much, Raffik, for your presentation today. Always a pleasure to work with you and have you join us. Also, a huge thanks to everyone who joined us today. Thank you for your time and your attention. And we'd, of course, love to have you on future webinars. So please stay tuned to your email. I'll be sending this recording out within the next 2 days for you. Please feel free to share with your team or keep reference. And if you have any questions, of course, please feel free to reach out to marketing@int.com or info@int.com. Once again, thank you all so much, and enjoy the rest of your day.